Okay, welcome everybody to day 5 of Advent of Code. Today's challenge is called Print Q, and part 1 looks kind of okay. I'm worried about part 2 actually. But today I won't be reading the story, I'm just gonna go and try to do it as fast as possible. And now the challenge is basically have these rules. So 47 has to come before 53, 97 has to come before 13, and so on. And then you've got some like pages. So each line is one page. And you have to check if the page is valid. So like 75, you have to look at the rules for 75. So it's the only thing it says is 75 has to come before 53 and 61 and 47, and it comes before all of them. So that's it. You move on to the next one and iteratively check all of them. That shouldn't be too much of a problem, I think. So I've already gone ahead and done the parsing. So this is the parsed input case. Now what we have to do is ideally we have to make a map and store like the first page, and then a list of all the pages that it has to come before, that have to come before it. No, it itself has to come before. So I'm gonna have to Google that, how to make a map in Go. Oh, Go maps seem a bit weird, but okay. All right. So it seems like we can make a map. Let's call it M. And so the key type is gonna be an integer, and the value type is also gonna be an integer. Is it gonna be an integer? No, it actually has to be an array of integers. Yeah, something like that. Now we have to fill this map up, so we go for rule, or actually I have to put an underscore here, rule, and that in range of all the rules. And then what do we have to do? We have to check. So let's do it the long way. So the key here is going to be rule of 0, and the value is going to be rule of 1. And we have to check if m, right, the autocomplete does not work. So let's see. To make the map, of course, make, right, now that the map is made, can we do anything? No. Okay. So if m of key, I guess that's it. Oh, wrong brackets. So if the key exists, we just append, right? So we do m of key equals, where is the equal sign? Equals append m of key and the value. What's this? Non-Boolean condition in if statement. Oh, because that's not the right. I was looking at the wrong thing, it seems. Oh my god. There are actually no good map examples. Go map contains. How to check if a map contains some key. Are you kidding me? You need to. Oh my god. Okay. Um. So yeah, we have to do it like so. It seems we don't care about the value, or do we? Um. Maybe we do, but it's fine like that. Okay, like that. And then we check it like so. Okay, we're in business. And then what do we have to do? If it doesn't exist, we just have to create it, right? So we do an MP equals an int array with the initial value of value. Oopsie, oopsie. And that should be it. So now we have the map. And now we can go and check the pages. So we can do it like that, page equals range of pages. And now for each page, we have to find and look through all the consecutive elements, okay? Necessary guard around access. What guard? Hmm. Make another function for this. It's gonna be somewhat cleaner. Let's just call it check, and we can practice making Go functions. What do we need? We need a map. Let's call it M. It's gonna be a map of whatever we have down there. And so we need this map. We need the current rule and the rule, right? And the rule is going to be an array of integers. And what's it going to return? A boolean. No, it's not going to return a boolean. Yeah, it can return a boolean, yeah. It's fine. Okay. And now what do we have to do? If should be a page. This should be a page, yeah. This element is gonna be map of this element. Now if rule I'm guessing it would be no nil. So if there's no rules, it's fine. We can return true. Otherwise, we have to check everything. So yeah, we go. Page. Current page, and I don't think we need this. All right. So if the current page is equal to this page, we can just return true. Otherwise, if does the go have array contains method? So there's supposedly a slices package that I can use. Let's try it. So if slices dot contains, all right. So if the slice page, no, slice rule contains the current page, that means the rule is broken. So we can return false. And eventually we should arrive here, but in case we don't, return true. Let's just put break here. All right. So now we just check for all the items here. So this p range of page if check of we need to put in the map the p and the page. If not, so if this is not true, let's put in a okay boolean. Let's say it's true, and if it's not, we say it's not okay anymore, false, and we just break. Now if okay, we need a sum, so let's say a sum is 0, and then we have to take the middle element, and so sum plus equals page of len of oopsie page /2. So the length is 4, we divide by 2, it's 2. No, if length is 5, we divide by 2, it's 2, and it's fine. Yeah, this should work probably. And then we just print the sum. Right, let's see. I suppose we're gonna get an error. Oh, there's no error, nice. 1, 4, 3. Let's see. Yeah, so it's 1, 4, 3 as well. And well, let's see if I put in my input. What do we get? 5166. And yeah, that's the right answer. All right, part 1 done. 15 minutes. pretty good. Now let's go to part 2. So while the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. After taking only the incorrectly ordered updates and ordering them correctly, their middle page numbers are whatever. Adding these together produces 1, 2, 3. Find the updates which are not in the correct order. What do you get if you add up the middle page numbers after correctly ordering just those updates? Oof, that's gonna be a tough one. So first of all, I'm gonna make um an array with unordered pages. It's gonna be an array of ints, I guess. Oh, yeah, let's put it. What's the best way to do this thing though? What did I do it up here? Oh, I just put vars, okay. So var unordered pages and did I have to initialize them? Doesn't look like it. It's fine. So if okay, do this and else append unordered pages or page, yeah. So now we move on to part 2, order so how do we do that? We have this. So my guess is when we encounter the wrong placement, so like this is a bit of a bummer. So 75 is incorrectly ordered. Let's say 75, 75, 29. Is it? What about 97? Yeah, 97 should be before 75. So if we go 75 and then let's say 75 is okay, and then we check 97 and we go from the beginning and we encounter this one. See, alright, that's not good. Should we swap them? No, we can't swap them. We should just put this in front of 75, probably. Is this valid? So if there's any numbers before it, I mean, that should be the only, not sure about that. Well, I'm not sure about this one. We can try coding it, but I'm not sure if it's gonna work. It's a really naive solution, I think. So whenever we encountered like 97 should be before 75, which is okay. We can plop this in before 75. But then what? Does this disturb anything else? So there are more numbers. I don't think it does, actually. I think we should be fine by doing that. So I'm not sure. Let's try. Um, well, actually, yeah, let's do it separately. Maybe we could do everything in this loop, but I think we're fine. So let's just copy everything, and we do unordered pages, and we have this check function here. So we check if DSP is okay, and if it's not, what do we have to do? So one of the things we could do is we could return the the information where it failed. So this is like 0, and this, oh, we need parentheses here. This should also be 0, and here we put current page, I guess. Maybe we should just use an index. Maybe, I'm not sure. Yeah, maybe an index is better. So we put I here, like that. And then actually this has to be -1, just to make sure it's consistent. So yeah, we check. And actually here I have to do, oh, check if it's not Boolean, like that. Now, we know this check is gonna fail, so we don't need an if. We just need the so we set an index, right? So let's check M, P, and page. Okay, now we have the index where it failed, which means we should stick it before that index. So we should place it at that index and then shift everything forward. We can probably just write a function to do that. Function insert at. Yeah, I think that should work. So we have list of index, and then we have I, which is going to be an index, and then I guess J, which is also going to be this. Should we name this array list? Let's do array. So what do we have to do? So we have to place it before that. So we have to shift everything forward. So X is gonna be array at position j. This is just a temporary way to save it. And now we need the what's the best way to do this? So we have to shift, and we do that by, well, the best way is to just define k, I guess, at j, and then while k is more than or equal to I, we should keep shifting. So first thing first, reduce k before we forget, and then we just do array of k equals array of k minus 1. Sounds sensible, yeah. Done with this, we do array of minus 1 equals x. I think that should do it. I hope arrays are copied by reference, but if not, we're gonna see. Well, actually, I can try. So let's print, I don't know, pages of 0. I think I have a problem somewhere. Oh. Yeah. Or we can print, or now we can insert add. So let's say pages of 0. Pages of 0. So let's insert first position, whatever is it, position 3, and then let's print it again. Now let's see what happens. Unexpected. All right, yeah, because I copy pasted. Let's can you stop being so annoying? I minus minus whatever. What's this append here? What's the problem? We need. No, this is old. We don't need that. This okay is also old. We don't need that. And I've mistakenly deleted this. All right. And what's the problem here? Value is not used. Which value is not used? Oh yeah, we need to save it. Append like that. All right. All right. Let's see what happened here. So we took pages and we inserted the third element in the first place. So this is $72, which we inserted in first place. And we should do it like that, I guess. This is more appropriate. So yeah, we took 72 and inserted it here. Okay. I think that should work probably. We'll see. Um, so what do we have to do here now? We have to oh, we actually do have to check if it's okay. If not okay, we have to insert at p. So the problem is, what do we return here? We return the current page, so where the problem is, and we have to insert it before that. So basically we have to insert it at this place, right? Yeah, I think so. We just put I and the current index. Like that. So what's the oh yeah, we need the whole page. And yeah, well, I'm not really sure. So we're gonna print line. I'm gonna print this page. This might be a problem because we're changing the page. I might have to do it by indexes, but let's run it. So let's see what happens. And let's put in the test. Okay. And let's delete this. All right. So let's check 97, 75, 47, 61, 53, 61, 22, 13, 97, 75, 47, 29, 13. Well, this actually looks like it's working. So yeah, let's comment that. And let's define another sum, or let's just put this sum to 0 and then do this again. Sum plus equals page length of page divided by 2. And then I'll just the sum 3. Let's hope this works. I'm gonna go to the real input now. And we got a bit less. I'm not sure if that's a good thing or a bad thing, but I feel so relieved right now because that's the right answer. One gold star closer to finding the chief historian. And this completes day 5. Almost 34 minutes, which is pretty good, I guess, with me struggling on this split keyboard with English layout and with Vim. I know I'm not using Vim that much, but yeah, I always try to complete it as fast as possible, and then I'm just using shortcuts. I mean, cheating shortcuts, as in not using Vim, but the things I know. So I guess I'll have to reserve a bit more time for one of the weekend challenges and like try to do it keyboard only, keyboard shortcuts, Vim shortcuts, or and do it the Vim way. So yeah, that's it. We've got 10 stars already, as you can see here, and looking forward to day 6 tomorrow. But first, let's just write a quick readme. What happened? 5. Parsing was a bit more involved, but nothing like last year though. part one was easy. Easy part two as well after some. Well, this year is going pretty well so far. What's wrong with Wim? Alright. How do I make a star? Oh, like so. Alright. And let's put in another smiley just because we can. And yeah, that's it. Let's do this. So let's see, git status. Looks fine. Git, let's add everything. Day 5 and git push. And I think we're done for today. Thank you for watching. And